Hello again, pirates. Welcome back. All right, today we're going to do section who knows what. Anyways, this is going to be chapter 9 review. We're going to be classifying conics. We're also going to review over the conics that we've gone through in class. I'm going to provide a little cheat sheet, if you will. And make sure you have your notebook, pen, pencil, highlighter, a straight edge, because there will be some graphing, not too much. All right, let's move on. All right, learning target or the objective. Students will learn how to classify a conic and write it in standard form. All right, you don't need to write this down. So, conic is a curve generated by the intersection of a plane and a circular cone. So this is what's actually happening. This is how we come up with our circles, parabolas, hyperbolas, and ellipses. We're also going to be dealing with an equation in that format that you see there in the bottom. You don't need to copy this right now. Unless you really want to, that's fine too, of course. Also, something to make note for that equation in that form, make sure to note that A, B, C, D, and F are all real numbers. Okay, the next part I'd like you to copy down. All right, in the following equation, the point HK is the vertex of the parabola. So make sure you make note of that. You don't have to copy down the whole sentence. Vertex of parabola. HK is the center of the other conic. So we're talking about the ellipse, hyperbola, circle. All right. And so this is the little cheat sheet that I'm talking about. So these are things that we've already gone over. This, the circle, sorry about the beeping. The circle we talked about before the winter break. So you have something that looks like this: x minus h quantity squared plus y minus k quantity squared is equal to r squared. Remember the r squared, that or r is going to represent the radius there. The h and k, that's going to be representing your center. Make sure you have that written down. And also make note that for the circle, you're going to have an addition sign right in there. All right, so for the rest of the conics, you're going to have horizontal or vertical type of situations. Parabola, you should have seen this in con. So you have something like that. Make sure you have that copied down. And then I'm going to provide you with graphs of each type, horizontal and vertical. Go ahead and copy that. The graph doesn't have to be beautiful. It could be a little generic type of graph, as long as it shows each direction, the horizontal and the vertical. Then we have our ellipse, which we've also seen. All right, and then things to remember about the ellipse, you might want to highlight or circle the addition sign there. And another thing you want to make note of is that your a squared, when it's in this format, your a squared is bigger than b. All right, remember that. So the a number, the a squared number, is always going to be bigger, still big. So here we're going to say still b. All right. So make sure you make a note of that when it's in that format. And then here you go. You have a generic graph for each of those. Go ahead and copy that. Again, pause it here and do a generic little graph. Finally, we have the hyperbola. And another thing you want to make note of for the hyperbola will be the minus this time, right? And for the hyperbola, A doesn't have to be bigger than B. A doesn't, whatever. You guys can write it down. A does not have to be bigger than B, okay? And notice that there are some differences with each one of those equations and formats. And here goes a generic graph as well for the hyperbola. And remember that the hyperbola has asymptotes. All right, moving on. Make sure you have everything copied there. Circles. Okay, so if you have something that looks like this: x minus 1 quantity squared plus y plus 2 quantity squared equals 16. All right, what if everything was multiplied out? What would that look like? It would look like that. Now, oh no, where did the Lopez get all this mumbo jumbo from? So we know that this means to write that out twice. So that's x minus 1 times x minus 1. plus y plus 2. And then we just multiply everything out. We're going to move the 16 over. Not yet, but at the end. Okay, so it should be a plus 1 there. And then here we'll have y squared. That should be 4y plus 4 equals 16. Combine your like terms, please. So like term, moving that 16 over. So 1 plus 4, that's 5. So we have plus 5 technically. And then we're going to take the minus 16, and that's where we get the negative 11 equals 0. All right, that's where that's coming from. All right, now let's say that we have an ellipse in this format. So now this one I also want to expand it out. But the first thing I want to do, because I know we hate the fractions, is get rid of the fraction. So I'm going to get rid of that denominator of 4. So again, let me show it to you completely. And we're going to go ahead and multiply the whole thing by 4. Make sure you distribute everything. So the 4 will cancel out with that 4. And we're going to have x minus 1 quantity squared plus 4 times y minus 1 quantity squared is equal to 4. Make sure you have that, please. And then you could go ahead and expand or multiply this bad boy out. All right, so make sure you do all of that. Oh, snap. Negative 2x. All right, distribute the 4 in here. And then you want to start combining your like terms. Again, the 4 that you have hanging out there, make sure that you move it over by subtracting once you're done. All right, so we'll have the x squared plus the 4y squared and minus the 2x minus the 8y. And then like term there and there. So that's going to be a positive 5 there. And then we're going to subtract that 4. So that's where we get the positive 1 from, equals 0. And that's what it would look like. That's where it's coming from. All right, just in case you needed it. All right, now for the parabola. I'm not going to expand this. So now you know where it would come from and how you would need to expand it. And that's what we would have as a result. We would end up with y squared minus 12y plus 4x plus 4. Hyperbola, same deal. If we have it in that format, again, I would multiply by 9 to the entire equation to get rid of that denominator of 9 and then expand it. So once we do that, we would end up with 9x squared minus y squared minus 72x plus 8y plus 1 equals 0. All right, make sure you have all of that copied down. Now, when you have these equations expanded, how do you know which one's going to represent a circle, ellipse, hyperbola, parabola? You may want to copy this down. If you want, I know it says pencils down, so I'll leave it up to you right now. You could copy it down after or copy the parts that are beneficial to you. So you want to pay close attention to the parts that are squared and the parts that are not squared, or the terms that are squared. The other thing you want to look for are the coefficients in front of the squared terms. So we're looking at just about all the squared terms and their signs. Boom, that's a biggie. All right, so for the circle, what should I look for? For the circle, I need to look for both x and y need to be squared, okay? I also need to look for their coefficients, making sure that the coefficients are going to be the exact same number along with the sign. So if we look at an expanded equation such as this, notice that we have coefficients of 1, so that's the exact number, and they're both positive. And notice both x and y are squared at the beginning. Ellipse, things to look out for. X and y are squared. Coefficients are going to be different now. Make sure you copy this. And their signs are going to remain the same. So again, notice that x and y are squared. The coefficients are different. We have a coefficient of 1 for x squared, and we have a coefficient of 4 for y squared. And then we have the same sign. They're both positive. Parabola, what to look out for. So this one, either the x or the y are going to be squared. Not both. Not both. That's the biggie. All right, hyperbola. Both x and y are going to be squared again. Coefficients are going to be different. And the signs are also going to be different. So here we go. Again, this y squared has a coefficient of 1. That 9 is positive, right? And then the sign in between the x squared and the y squared is negative. So those are different signs. All right. You also want to copy this too. So things to also consider for a circle. A circle, it would be a circle if a equals c. Parabola, if a times c would be 0. For an ellipse, a times c is greater than 0, so positive. Hyperbola, a times c is less than 0, so negative. All right, let's go ahead and identify the conic section that the equation represents. So make sure you copy A, B, C, D down and determine whether it's going to be hyperbola, parabola, circle, ellipse, okay? So you want to look at your notes again and see what's what. Okay, so if I look at letter A quickly, I see 1 is squared. Only the y is squared. So if I look back at my notes, boop, 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 I should be saying that this is going to be a parabola. If I look at letter B, both the x and the y are squared. Now I'm looking at the coefficients. The coefficients are different, and the signs are different. Hyperbola. Letter C. I notice that x and y are both squared again, the exact same numbers in front of them, and they have the exact same sign. They're both positives. This is going to be a circle. If I look at letter D, again, x and y are squared. They're both positives, but we have different coefficients here. So this will be my beautiful ellipse. All right. So those are things you want to go through. This one you don't have to copy down. You just want to go through it and make sure that you understand how to identify each one of the conics. And then I will give you the answer so you can pause it throughout so you can figure it out. And go through the same type of questions that I did in the previous set. All right, guys, all done here. Oh.